Hello and welcome to the course of manufacturing method. In this course, so far we have studied about welding. We are in the topic module welding. In here we have already studied about fusion welding, and for solid state welding we have already studied about resistance welding in last class. So today we will be taking the lecture. We will be seeing about mechanical solid state welding. So in mechanical solid state welding, what happens in mechanical solid state welding? The mechanical energy will be converted so that it can be used to join two similar or dissimilar material. So let's start our lecture with lecture objective. So the lecture objective for this lecture is to understand about solid state welding technique using mechanical energy. Firstly, secondly, to get a detailed description of cold welding, ultrasonic welding, and friction welding and friction star welding. So these are the topic that we will be studying today. That first about cold welding, next ultrasonic welding, friction welding, and friction star welding. These are the four mostly used mechanical solid state welding. So as it now name suggests, the solid state welding, that means here no melting will occur. So the joining of similar or dissimilar materials will be done by using mechanical energy such as friction, pressure, or ultrasonic vibration in the solid state without any filler material, and this process is known as mechanical solid state welding. And this process is widely used in mechanical welding process. The widely used mechanical welding processes are cold welding or roll bonding, ultrasonic welding, friction welding, and friction star welding. These are the process that we were going to study today. So first there is cold welding or roll bonding. So this cold welding or roll bonding, here plastic deformation of the solid will be involved in this process. This is used to join small workpiece that made of small and ductile metal, and in the welding of two dissimilar materials, by this process brittle intermetallic compound may form. So maximum bond strength that can be available when welding of two similar metal has been done. So here for cold welding we prefer the welding of similar metal. The pressure required for welding is given by the die or rolls, and the surface preparation is very important for interfacial strength. So getting the interfacial strength or good interfacial strength, what is important? The surface roughness is very important. Surface preparation is very important. Next, when the pressure is given by a pair of roll, at that time it is called roll bonding, and it can be done at elevated it can be also done at elevated temperature, or the maximum or good strength of the joint can achieve in elevated temperature, and that process will known as hot roll bonding. Hot roll bonding, this process is applied for cladding, for aluminum cladding, that is cladding of pure aluminum over precipitation hardened aluminum alloy steel, stainless steel cladding for corrosion resistance over the mild steel, and for making of bimetallic strip that is used in thermostat or similar device which can use two layers of material with different thermal expansion coefficient. that can be made by using this roll bonding or cold welding process. So here the typical schematic diagram of the roll welding process has been seen. See here that two parts are to be welded has been shown here, and by the force that is given in by using the rolls, the welded part can be made. And if the those part to be welded are those part which are to be welded are preheated, at that time what will occur? If it is preheated, then if it is preheated, then what will occur? Then the weld joint or diffusion, the diffusion in the interface will be more, so strong weld joint can be achieved. So this is for cold welding or roll bonding technique. Next we will see about ultrasonic welding. So in case of ultrasonic welding, the ultrasonic vibration or a continuous vibration will be given to the workpiece by using a horn, and that horn is nothing but the tip, that is the tip or the probe. That probe used in the ultrasonic welding is known as horn. And the here the fairing surface, means the contact surface, is subjected to static normal force along with oscillating shearing or tangential stress by the tip of a transducer. That tip of the transducer is known as horn, and the frequency of that oscillating vibration is in the ultrasonic range. What will occur? Due to this axial and tangential stress, the friction will be generated, in the fairing surface. So plastic deformation may occur. In the fairing surface, and a good bond in the interface may created, and that bond is created at a temperature 1/3 to half of the melting point temperature. So the temperature rise in the interface is very low, and it is very less from the melting point temperature, so there is no chance of melting the material. So that's why in the solid state, the joining good bonding strength can be achieved by this process. This process is very versatile, and it is a reliable process for joining of metallic, non-metallic, similar or dissimilar material. This process is extensively used for joining of plastic for packaging and foils for automotive and electronic industry. So mostly used, this ultrasonic welding process is widely used for packaging in plastic industry, for joining the foil in automotive industry and electronic industries. So let's see about the schematic diagram of the ultrasonic welding. See here, from a vibration generator, vibrating signal or oscillating signal is given to the transducer. What is transducer? Transducer is a device which can convert the energy. That means in this case it is converting the electrical signal to mechanical vibration. So that thing can be done by using that transducer. So after the transducer, that vibration should be somewhat amplified, and that amplification is done by the booster. And the next part from the booster, the vibration is given to the tip of the transducer, that is horn. And in the horn, that horn is delivered that vibration to the workpiece, to the part to be welded, that is placed in a anvil. And that part, due to that vibration, that that part will undergo plastic deformation, and due to plastic deformation there will be a bond generation in solid state, and this process is known as ultrasonic welding. Now we will see about friction welding. So it is this friction welding is most important mechanical welding process, mechanical solid state welding process, and nowadays friction welding has now very much greater importance as the solid state welding is having greater importance, and friction is a very natural phenomena and it can be achieved very easily. So for friction welding, the energy required for welding is given by the heat that is generated from friction of the interface that to be joined. So from the friction of the interface that to be joined, the what will occur, the friction welding will occur. So the energy required for welding is given by the heat generation by the friction at the interface that are to be joined. And here the process is like one workpiece is fixed while the other workpiece is rotated in an axial force, is rotated, and an axial force has been given which increased when adequate amount of heat is formed in the interface. So what is happening here? So one workpiece, one part is fixed and another part is moving. So when the moving part when due to that moving due to that relative motion, what will happen at the interface, there is heat generation due to friction, and when there is adequate heat generation, that means the interface is in red hot condition, at that time what will happen, an axial force will be given to the moving body, moving part. So the moving part will be added to the fixed part, and a complete workpiece added to the fixed part, and uh, what will occur, and the bonding will form, and when the bonding will form, at that time a quick stopping of the rotating workpiece will occur due to as the bonding will be fixed. So this is the process of friction welding, and in the friction welding, weld zone is very narrow sized, narrow sized, and this size will be depending upon three things: the amount this on depending upon the size, the size that size is depends upon the amount of heat generation, thermal conductivity of the workpiece material, mechanical properties of the material being joined at elevated temperature. Now shape of the weld joint depends on the rotational speed and the axial force. Oxide and other contaminants move outwards of the joint, so we can very easily get high purity weld joint, and the oxidation scale or oxides can be very easily chip off from the workpiece. Now there are three type of friction welding. So in case of friction welding, solid or tubular part of various material can be joined first. Secondly, flash may be formed. Flash means excess material, that material which may come out due to that axial force, that flash flash may be formed due to upsetting, and this flash can be removed by post machining operation, by post machining. Next, there are three types of the friction welding. Those are inertia friction welding, linear friction welding, and friction stir welding. So all of those three we should learn, and in this lecture only we will be seeing about inertia friction welding, linear friction welding, and friction stir welding. So let's start with inertia friction welding. As its name suggests, in inertia friction welding, the inertia of rotation has been, inertia means the energy, that is energy of rotation is stored in a flywheel. Then again this energy, so first the energy of rotation is stored in a flywheel, and that energy will be released when that kinetic energy will be released when the workpiece, the two mating part came into contact, and the total energy will be released at a time, so that high friction may form at the interface, and due to that high friction, what will happen, good strength welding can be occurred. So this process uses a flywheel to supply kinetic energy to the rotating part. Here in this figure, here in this figure, what we can see here in this figure, we can see that there is rotary workpiece and there is stationary workpiece, and a flywheel is there, and that flywheel will store the energy from the drive motor, and that will deliver that energy at a time when there is the axial force. Due to the axial force, the material, the two workpiece came into contact, and by this process circular shaft can be joined for automobile turbocharger impellers. So this is the effect, and this is the application for inertia welding. Next, linear friction welding. The linear friction welding, what will happen, the friction is generated by the linear reciprocating motion of the workpiece. So due to linear reciprocating motion of the workpiece, the friction will be generated, and this process is capable of square rectangular joining for square rectangular part as well as round part. Metal and non-metal can be welded. Here in this figure, you can one can see that by applying force, the two surface will come into contact, and then a reciprocating motion will be seen. Due to that reciprocating motion, the frictional heating will occur, and due to that frictional heating, the material part will be joined together, and a flash will be generated. That flash can be machined later on. So this is your linear friction welding. So again, for recollection, what we can say, we have seen that for inertia friction welding, there is one stationary job and another is rotating workpiece, and the friction will be generated by rotation. Next, for linear friction welding, the friction is generated by reciprocating motion. The reciprocating motion of the one of the two joining part. So due to that reciprocating motion, friction will be generated. So in these two cases, what is the case? In these two cases, the motion is the friction will be generated on the workpiece only, and there is no third party, that means no external probe is involved. But unlikely in case of friction star welding, the heat of friction is generated in the workpiece by using a third body which is rubbed against the two surface that to be joined. A rotating non-consumable, here in this case, a rotating non-consumable probe is plunged into the joint, and joint contact pressure. Due to that contact pressure, what will occur? Friction heating will be generated, and in this case, in the friction star welding can be done in a vertical milling machine. So a vertical milling machine can very easily converted into a friction star welding machine with some modification. So in this case, in this friction star welding of various metal, non-metal, polymer, composite can be done for aerospace, automobile and shipbuilding industry. In friction star welding, high quality material with minimal pores and uniform material structure can be obtained. So high quality material with minimal pores and uniform material structure can be obtained by friction star welding. Now these are the about friction star welding. So hope you understood, and if you have any problem you may ask during the live class. Thank you.